Good afternoon, everyone. Welcome to today's webinar. My name is Anand Bora, Customer Success Account Manager at Moldex 3D North America. Today, we are going on a deep dive into compression molding simulation, specifically how Moldex 3D helps predict defects and optimize the process. Whether you're new to compression molding or an experienced practitioner, I hope you all will take takeaways with actionable insights today. So let's get started. Here's a roadmap of what we will be covering today. We'll start with an introduction to compression molding, what it is, its advantages, and where it's used. Then we'll walk through the key features and benefits of Moldex 3D's compression molding module. After that, we'll look at the standard operating procedure for setting up a simulation inside Moldex 3D. And then finally, we'll walk through two detailed case studies to see their capabilities in action. Let's start with a brief introduction. Compression molding has been around for decades, but simulation of this process has historically been underserved compared to injection molding. Moldex 3D has invested significantly in this area, and today I'll show you why that matters for your product development and manufacturing decisions. It's one of the simplest and most economical way to manufacture rubber, thermoset, and even thermoplastic parts. Process involves placing a charge, a pre-measured amount of material into an open mold cavity. The mold is then closed under pressure, forcing the material to flow and conform to the cavity shape. Heat is applied to cure thermosets, while thermoplastics are cooled to solidify. Once complete, the mold opens and the part is ejected. Any excess material, so-called flash, must be trimmed off. It's very simple in concept, but the process variables significantly impact the part quality. Compression molding handles a wide range of materials from rubber and silicones to thermosets, composite like BMC, SMC, and even some thermoplastics. The material type strongly influences how we set up the simulation because each has different rheological and thermal behavior. We'll see this reflected in the simulation challenges slide coming up shortly. Like any process, compression molding has trade-offs. On the advantage side, tooling costs are generally lower than injection molding. Material waste is minimal since charges are pre-weighed. Cycle times can be shorter for larger parts, and it is well suited for high-value compounds.